Hello, my name is Andrea Ibarra, and today I will be presenting my final paper called Hydroelectric Dams and Their Impact on Diadromous Fish Migration. Here is a quick outline that we're going to skip, and we're going to get right into it. Hydropower is a form of emission-free energy production because it just harnesses the power of water. It's reliable and affordable, and it represents 73% of the world's renewable energy. The dams have a long lifespan of 50 to 100 years once they're constructed. In the United States, they need to be licensed every 30 to 50 years by the Federal Energy Regulatory Commission. They also present environmental challenges, mainly their blockage of fish migration that leads to population reductions of diadromous fish. These fish are fish that migrate between fresh and ocean water, and they're important because they are a crucial node in food webs. They have a lot of trophic flexibility because of their different life stage, and they affect ecosystem stability and resilience. They also link marine and riverine habitats by transferring nutrients, and their loss of abundance and diversity can alter this nutrient equilibrium of the trophic levels and can put the ecological systems into collapse. They're also important for humans because they represent 40% of the fish consumption of the world, and they also generate about $34.5 million every year, and they also provide a lot of jobs through fisheries. So their loss also threatens food security, economic stability, and the livelihoods of millions of people. Their habitats are in danger because of hydroelectric dams blocking rivers. Currently, only 23% of the world's rivers flow uninterrupted to the ocean, and there's a lot of dams around the world. There's over 6,000 large dams, and in the United States alone, there's over 2 million large and small dams. Because of these dams that are blocking migration, they're reducing the food abundance and also increasing the mortality of these diadromous fish by either directly killing them or injuring them. They have been a sharp decline in their abundance. They have declined by 76% globally in the last 50 years, as we can see in this chart from the 1970s to 2015. And dams are the main reason that they're declining, and they're also the main threat of freshwater biodiversity. Here in this other chart, we can see that about 47% of this decline is due to habitat degradation and change and habitat loss through these hydroelectric dams. However, they're having solutions to this blockage of migration through fishways. For example, fish ladders that allow the fish to jump and cross the dam, trap and hulls, which is putting fish into trucks and driving them through the other side of the dam and then releasing them. There's also spillways that allow the fish to completely bypass the turbines. There's also improved turbine designs that make them fish friendly by using dull bladders, making the gates bigger and rounder with fewer gaps. And they also reduce the speed of the water and the turbulence so the fish don't get knocked around and injured. There's also the natural bypasses and fish lifts. When the natural bypasses, there's canals that connect the two sides of the dams. And also the fish lifts are just like elevators, but for fish that just took them from one side of the dam to the other. However, these fishways are not perfect. They are a source of selective processes for physiological and behavioral traits because not the entire population is using them. So only the ones that use them are the ones that survive. And sometimes the ones that use them are the ones that have the instincts to use the fishway or are small enough to pass through the grates. And so there is a selection for these certain traits. However, this selection may take a long time, but in the meantime, it's reducing the behavioral and genetic diversity of these fish populations, which can also negatively impact their adaptability to other environmental challenges. These fishways can also create ecological traps because by creating reservoirs, the upstream habitats may lose their ability to act as spawn sites or nurseries, and also because usually there's no a fishway for downstream passage, so fish get trapped upstream and they cannot complete their life cycles, which also reduces their population. So some of the recommendations that I came up with are the use of different fishways at the same dam to reduce those selective pressures and to allow the dissemination of preservation of various traits, and also proposing the use of different fishways as a part of the licensing process for the Federal Regulatory and Energy Commission and NOAA. And also I propose adjusting the licensing periods from 30 to 50 years to 10 to 20 years. So these these requirements are able to keep up with research because, for example, all of those papers that I used for the artificial selection, they have been coming out since like 2015 or 2020, for example. So a dam that was constructed in 2010 is not going to take these new insights into consideration. And also continuous ecological monitoring. Here are all of the sources that I used. Thank you.